just to give a tiny bit of flavour, this is an area of excitement for the Energy Institute and Yorkshire and Humber specifically. So we're joined today by David Talbot, the current chairman of the Humber branch at Energy Institute, who's going to be supporting myself in terms of the administration and Q&A section at the end. But more importantly, we've got Dave Tomkin on the line, which is great. So David has nearly 20 years experience in the gas industry. Initially joined the industry as an apprentice emergency service engineer at Transco back in 2001. Before fulfilling roles in the distribution network, National Control Centre at Northern Gas Networks as a technical engineer for British Gas. He was also a technical manager for the Gas Safe Register. He's currently studying an MSc in gas engineering and is a qualified incident investigator. Was awarded IGEM's first ever Engineering Technician of the Year award. He's a fellow of the IGEM and sits on the council of IGEM as well. Additionally, he has sat on various panels for numerous industry standards, committees and working groups, and has previously been a technical consultant and author to Gas Safe Register's official magazine. More likely he's working in this area of hydrogen, and I'm really excited to be on the call personally to listen to what he's got to say, and hopefully we'll get some exciting Q&A at the end. So I'm going to pass over to Dave, and hopefully we'll come back in half an hour or so.
Yeah, I've got your slides up here, so I don't know if you need me to continue through the Energy Institute slides because I'm in control at the moment, but I'll move my way through. It's good to meet everyone anyway. As I say, I'll move through. Myself, my name is David Tomkin. I work for Northern Gas Networks as part of the H21 programme, and I'm joined today with David Talbot, who's been introduced, chair of the Humber branch, and Mark, chair of the Yorkshire branch. So today I'm going to, let's say, go through H21 and pioneering a hydrogen network, as we call it. My job here at Northern Gas Networks is the H21 system modeller. And what that is my primary role is to assess the implications of the hydrogen flows on the network and perform network analysis, model the behaviour of flows within the network, start looking at system sectorisation, pressure loss across the mains and pipeworks, velocities, etc., as well as the other projects we do. Before I move on, because I'm always terrible for the bandwidth of my computer, I will stop the video. It's not because I'm doing anything else. It's so sweating. It's just I find it improves things, so I'll just stop that now. Right. So what I'm going to cover today, I'm going to go through a little bit about who we are at Northern Gas Networks, a brief overview of the need for change, and then we'll really get into the H21 project itself and the three main phases of the project. I'll cover a little bit about Hydeploy too, and for those that don't know that, that is the blending of hydrogen, the up to 20% blending, that is not directly part of the H21 programme, but is something that Northern Gas Networks are involved in. And then I'm going to briefly talk about the other projects that NGN have, including our integral site with our hydrogen houses. And hopefully at the end there'll be some time for questions. Please go gentle. I don't know everything about everything, but I'll certainly do my best to answer what we can, and within the bounds of what we can release at the moment. So who are we? Northern Gas Networks, for those that don't know, are the gas distributor for the north of England. We transport gas to around 2.7 million homes and businesses across Yorkshire, the North East and Northern Cumbria, through a network of around 23,000 miles of pipeline. And within our network, we can see we have a sub-branch of different districts from Cumbria down to East Riding. And within that network, within that area, we have two separate LDZs, as we call them, the North East and the Yorkshire. So there's two separate networks within our network, if that makes sense. But that's where we are, and we're one of the main distributors in the country, as you can see. SGN to the north and the south, Cadent and Wales and West. So really the need for change. I think it's fairly certain now that the consensus is out there that climate change is a thing. And it's one of the most significant technical, economic and social changes facing the world today. And the UK, along with most of the world, recognises the challenge that climate change is going to bring. And in 2019, we in the UK committed to reaching a net zero emissions by 2050, having already committed to reducing carbon emissions to 80% of their 1990 levels by 2050. This was part of the UK Climate Change Act 2008. But prior to the Leeds Citygate report, which I'll touch on next, Little investigation has been given into the opportunity to decarbonise the UK gas networks at a scale that's going to be consumerate with the climate change targets needed. But why the gas grid? So why are we looking at the network and why was it thought of? In the UK and Great Britain, we have a world-class gas network which heats around 83% of buildings, as well as providing nearly almost all commercial and industrial heat, as well as feedstock for some, and is prime place to help deliver the actual energy that's needed for this. The network is well proven in providing this energy through a secure network which is unaffected by the weather. I think the resiliency of the network is something like 99.9%. I'm sure not many people can remember an uninterrupted or unexpected interruption of gas. The network's designed to meet this energy demand in what we call a 1 in 20 winter, which is an exceptionally cold winter, generally with all appliances on at a maximum peak. Something that was actually validated to prove just how resilient it was back from the Beast from the East back in 2018. That was vindicated how secure our network is. So, if this network could be repurposed to transport a zero carbon gas or a low carbon gas in some areas, it will allow the UK to capitalise on this paid for asset we've paid for these pipes in the ground as consumers, whilst also ensuring that customers don't experience excessive and huge amounts of disruption in doing so for their homes. Furthermore, it also provides the customers of the future the choice that we enjoy today as consumers, how we heat our homes, be it by gas, electricity, other fuels. The options will be there. It is not a case of one shoe fits all or one answer for everything. So the H21 timeline, it was born from in 2016 where the Leeds Citygate report was published by Northern Gas Networks, which confirms that the conversion of a major UK city, Leeds, is technologically possible and economically viable. Leeds was chosen not as a starting ground for the UK rollout, but more because it fits into a general view of the UK. It has bits of everything in there as a good starting point to try and get an idea. And following this, in 2017, on behalf of all the UK gas networks, that will be Cadent, SGN, Wales and West Utilities, a bid was submitted to Ofgem in the form of what's called an NIC, which I will mention shortly, and we were awarded £9 million by Ofgem, with a further £1.3 million coming from other gas distribution networks to deliver the first phase of this critical evidence. Joined us in the partnership with DNVGL, a leading research centre and research organisation, as well as the Health and Safety Executive Science Division. And at the end of 2019, the H21 project was received a further £6.8 million of funding to develop phase 2 of the safety case. There are other projects out there as well, such as the main one, emergency control valve, is the downstream of the meter programme, which is led by BEARS under what's called the High for Heat programme. But H21 is working to present the quantified safety evidence between the natural gas and 100% hydrogen network within the existing gas network. So we have a number of projects within the H21 programme. I'm just going to clear up a few terms that you're going to hear through this. Specifically, one's called an NIC and an NIA, because the project is made up of both of them. An NIC is in essence a yearly pot of money set aside by Ofgem for the gas networks to bid against for various projects, and it's specifically focused on low carbon, innovative, large scale projects such as this. So people will bid, the networks, as I mentioned, bid for this and are awarded money by Ofgem. An NIA, however, is an allowance that each network received from Ofgem as part of their price control settlement, which can be used for innovative projects that will benefit the consumer. So it's just to clear up what they are really moving forward, because I'm going to be using them a bit. So phase 1 of H21. Phase 1 was split into two phases, phase 1A and phase 1B. Phase 1A was centred at the Health and Safety Executive Science Division laboratory over in Buxton in Derbyshire. That was the asset collection and background testing on what was a world first test site that was built specifically for this over in Buxton. And that was testing a huge range of metallic and PE assets from valves, joints, fittings and pipes from across the UK and from various pressure tiers and diameters. and that was up to 7 bar assets. And as part of the UK's iron main replacement programme, a cross-section of these assets had been removed from the network. Some of them had been in the ground for up to 100 years. So on the specially built leakage rig, controlled testing was undertaken on natural gas and 100% hydrogen to see the evidence between the leakage levels between the two. And testing on that was completed in March, April this year. We then have Phase 1B, which is on the right-hand side here. This was undertaken at DNVGL's research station up in Cumbria, the Cumbria-Northumberland border, and when that itself is on the RAF Spade Adam Electronics Warfare Base. Testing there completed in 2020 in August, and this focused on consequence testing. And it mainly looked at the risks associated with leakage, such as failures, mains fracture, third-party damage, and operational repairs. It also included the construction of the 3 purpose-built houses you can see in the bottom right on our fantastically named High Street. Those houses were constructed to 3 main construction techniques: 1920s build, 1960s, and modern building standards to get a wider breadth of typical UK housing stock as we could. We then simulated hydrogen leaks from a newly installed ring main around, as well as a set of what we called the allotments, to see how gas tracked and migrated and moved underground under different soil conditions and different permutations, weather conditions, etc. on there, to see how it moved differently to natural gas. And that's really key, critical, and a better way to understand the consequences of any hydrogen leakage. Speaking of leakage, we also simulated large releases of hydrogen, undertook ignition potential and explosive limits testing, and that has given us a better idea of understanding the characteristics of hydrogen and how it operates under various situations, so to speak. And then right the way down to explosion severity testing and some initial operational activities, including purging, flow stopping, and excavation techniques. The reports for Phase 1A and B, I will mention now, are being completed. We are working to get those all together with the evidence to share with our industry partners before they are released. So at this time, the results of those testings I cannot discuss, so I thought I'd get that out there now, ready for any questions. Just should any questions arise from this, as you can appreciate, we're not in a position to publish those yet, but once we are, it will be announced. As part of Phase 1, we also started undertaking something called our social sciences. Now, as an engineer myself, I personally found this really interesting, and there was a lot of outcomes from this that I didn't expect and found it really different. One of them being that to the public, safety is not a major concern to them. It's they understand the safety that comes with their hydrogen, actual additional safety benefits, such as no carbon monoxide in there, but people give little thought about where their gas actually comes from, or electricity. They just turn it on and it's there. So that, to me, really gives a real good vindication about how safe and how good a safety record the UK gas networks have, that the first thoughts out of consumers' mouths isn't the safety, it's actually cost, which may be the barrier that they see. They do feel that we use a lot of terms that are difficult to understand, and we are terrible in the gas industry with our TLAs, or 3-letter abbreviations, such as NIAs, NICs, and you can see there CCS, SMR, ATR. But what we did find is they want to be brought along the journey with us. People can understand quite detailed technical information, explain it and retain it, but it's tell them facts, be honest with them. So if anyone's interested in the initial Phase 1 report, it is available on our website, so please do go there and have a look and read that. It is quite an interesting read. So I'm going to move on to Phase 2 now. Phase 2 of the NIC was funded with a further 6.8 million at the end of last year, and is another step to providing the evidence base for this. Again, with Phase 1, it's a collaborative project with the other networks, including DNVGL, HSE Science Division, National Grid, and Leeds Beckett University, who, I should have mentioned, were involved with us on the social sciences as subject experts in that. Phase 2 itself will be broken down into 4 main subsections: Phase 2A, B, C, D, and I'll start talking about a little bit of those in brief now. So phase 2A is what we call our appraisal of network operations. This phase is aimed to review and test and make recommendations to amend the operational and maintenance procedures required to work a network at 100% hydrogen. It's fantastic that there are talk about us converting and bringing hydrogen to people's houses, but as a network operator, if we can't physically work on it, maintain it, connect to it, repair it, what's the point? So this is the actual looking at how we run, maintain and operate a network based on hydrogen. To do so, we are going to build, and building has started, on a bespoke, specially designed distribution microgrid up at Spade Adam. That's going to be built alongside our high street houses, as you can see on the map on the left. The houses are on the right-hand side of that, with us building this distribution microgrid with various diameters to replicate the existing network up to 7 bar, from large diameters down to small, and that's going to allow us to do numerous operational testings as we would on the district to start getting an idea of how we would operate a network. And the procedures have been appraised by the HSE, with the test plan being produced to detail what goes on and looking at those procedures. So it's a collaborative effort between us all. And what's really exciting is, subject to their bid being successful, this will connect to National Grid, is their future grid. So it will be a transmission pipeline that National Grid will be installing there to connect to our distribution network right the way down to the houses. We will have a full beach-to-burner research centre on one site. So that could be absolutely brilliant for learning, research, training eventually, and just to get a wider implication. So really good stuff. And from my point of view as system modeler, it's also going to be used to validate network analysis software and the equations of state used in our network analysis to start looking at there. So it's going to be interesting when that gets going. Phase 2B is what we call our unoccupied trials. So we've secured a site in Redcar in Cleveland in which the section of the network is currently in use but doesn't supply any end users. Basically, it's a demolished housing estate. The network's still in place, still operational, full of gas, but it doesn't supply anyone. We aim to start building a test site there in January next year, with testing due to commence in March and end in late 2021. Its purpose is to establish the confidence in repurposing an existing network of undisturbed section of the network. So we will be isolating it from the current network and converting it to 100% hydrogen. We'll also then continue our operational and maintenance procedure research on there as the trial continues. But it's going to be a fantastic opportunity to pick up on any unknowns relating to the conversion. These pipes have been in the grounds for decades, and we have done some initial main surveys to see what's there before we dig it up, but we won't know what's happening until we start going. So it's going to be a really good learning experience to see how these pipes that for decades have been exposed to fogging, monoethylene glycol, odorants, where new assets haven't. It's also a fantastic public awareness. The public now, thanks to the mainstream media picking up on the hydrogen journey, have started to hear about hydrogen. There's hydrogen trains, talk of hydrogen planes, cars, which might add is our little car there, our hydrogen car. But up until now, a lot of the research has been done behind closed doors, such as at Spade Adam, Buxton, rightly so, but this will really bring it to the public. They'll see this, depending on what happens with coronavirus, the chance to visit, to see, and actually see this in action. So it's been a really good community engagement as well, and the local community are very much on board, local MPs, councils, colleges. It has real potential to start reinvigorating and starting the conversation. Phase 2C is what we call the combined risk assessment, quantitative risk assessment. So following successful demonstration on the grid and any unoccupied trials, a robust modelling software is going to be built on a risk model for hydrogen in the existing network up to the ECV. I will be honest, this is not my field of expertise, because this is some really clever modelling and risk building that is ongoing. But What we also have is the Hydeploy programme that I mentioned earlier, and they are doing exactly the same for downstream of the emergency control valve. So the aim will be in this phase is to compare and analyse and align the two QRAs for the two projects. And it's really important to do this at this time to ensure the compatibility of the adjoining systems, so i.e. upstream and downstream, that we don't have this disconnect moving forward, and to give us a real overview prior to commencing any community trials that are going to involve both projects. So depending on the outcome of that risk assessment, it might mean additional safety mitigations and tests are required, but as I say, it's an ongoing risk building, risk modelling software process. Phase 2D will continue the excellent work of the social sciences, again with our friends at Leeds Beckett University, but this will take it one step further to develop a suite of resources that are going to be used to communicate effectively with the public, because as I've mentioned and as I stress, it's so important we take the consumer on the journey with us. Informed customers who are equipped to make choices about their energy future are critical to the outcome of this conversion process. We've heard the term fake news quite a bit, sadly. So any misunderstanding, misinformation could lead to poor customer choices and unwarranted concern. In the worst case scenario, if there's widespread misunderstanding and misinformation, it could lead to a wholesale rejection of any conversion and the option of hydrogen could be lost entirely. So, as the network operator, we are the main point of contact with customers who are living within our networks, and it's our responsibility as the people who undertake the conversion to ensure that customers are properly informed and equipped to make the choices. So this is going to involve examining the language, tone and format of this hydrogen conversation message, and to allow all the gas networks to effectively communicate. So we are looking to build a glossary of terms, informative animations. There was talk of interactive events, but again, with the state of the world, we don't know what that will do. A beach-to-meter display that can be used at community engagement events, again, subject to what we can do. But whatever happens, they will all be underpinned by three core principles: that they will be accessible, easy to understand, and versions for people who may not speak English or who have difficulty in English. There will be no selling. The resources that we produce will be informative and help inform choice rather than persuade to use hydrogen. They also have a degree of candour. We must be open and honest with people and say what we know and what we don't know. So that work is ongoing. Now, that's phase 2 complete. Phase 3 of NIC, of H21. This is currently pending funding approval, but subject to that, we aim by mid-2022 to begin live trials and live conversions of actual homes on the network. Phase A of that will be 50 homes by mid-2022, as I say, and Phase B, an additional 620 homes or so, these are approximate numbers at the moment, by mid-2023. We haven't identified a full scope or full site as yet, but whatever site is chosen and finalised for this will include hydrogen production and storage up there. In addition, and this is why it's key that we engage with the Hydeploy programme now, new appliances are going to be required and work inside people's properties to convert and do a full conversion for those people to hydrogen. So watch this space with regards to phase 3. To supplement the main NIC bid, we have a number of NIAs. Again, I said I'd be using these phrases a lot, the Innovation Awards. So to support that, we have 5 main NIA projects at the moment. 2 of them we have just recently kicked off. The other 3 have not started yet, but will hopefully soon. The 2 that have started are the Occupied trials and industrial and commercial customers. Now, the Occupied trials, you might think, well, why have you started that when the funding hasn't been awarded for phase 3? We view this as our pre-enabling works. So we want to be able to be in a position to hit the ground running with those ambitious timescales when funding is approved. We don't want to be in a position where funding is approved and we're starting from a start. So this is starting to look at things like what legislation may apply, what the site may look like, where we choose, analysis of the networks. It's that sort of thing. So it's pre-enabling works to hit the ground running. Our industrial and commercial customers is examining NGN customers of the industrial and commercial and what mitigations they may need in place to convert to hydrogen. They have very different usage, very different needs, very different requirements to domestic customers. Can you interrupt a power station? Can you interrupt a hospital, etc.? It's looking at those, engaging with them sort of people to see what a hydrogen conversion will look like to them. To say they both started back end of last month, so we're in the early stages of them. Our hydrogen supply strategy will look at the first few years of conversion, how hydrogen might be produced, where the centres will be, but that has not started yet. The compatibility of services. Now, as someone who does network analysis, this feeds directly into that. We can analyse the networks, the mains, to see what pressures we may get, velocities, etc., on our modelling software. But that final connection from your property to the house needs to be looked at as well. Is it compatible with hydrogen? Are they the correct size with the anticipated 3 times volumetric flow that may need to go through the service? When do we start? Do they need to be replaced? When does that happen? So that's going to be a key important project as well. And then finally, the compatibility of components itself. And that will build and expand on those tests during phase 1 and advise on what gas components currently used in the network will either need to be tested with hydrogen or completely replaced. Again, it's not started, but we'll be looking at long-term exposures to hydrogen with those, whereas phase 1A only looked at mainly things like leak testing. So this will be gaskets, sealants, all sorts of a range of things that we use in the network to start having a look at. So that was H21 in a nutshell. I'm going to just talk a little bit about the other project that NGN are involved in, which is Hydeploy 2. Now, it's Hydeploy 2, it's not a sequel that went straight to video. We already have Hydeploy 1, which is underway at Keele University on their private network. But they have been successfully blending hydrogen into the natural gas network. And it's just, the aim being is a business as usual, in inverted commas, to demonstrate that the 20% blend into the existing network can be done. So the aim being here is the second phase of this will be done on Northern Gas Networks' public network. So the community of Winlaton in Gateshead will make history and play an important role in the future of hydrogen by becoming the first network to receive a 20% hydrogen blend. The 688 properties in the area, which includes a school, primary school, businesses, will receive the blend for around 10 months starting early next year. Free gas safety checks have been undertaken on properties within the area. Ongoing stakeholder and community engagement is ongoing there. What is great about the Hydeploy project is it can be seen as an enabling project. It starts the hydrogen infrastructure conversation going. If blending starts rolling out nationwide prior to full hydrogen conversion, it allows the kick-starting of that hydrogen economy, hydrogen infrastructure, production, storage, etc., ready for us instead of just flicking a switch and thinking everything's going to be 100% hydrogen. So it's a really important project, and if anyone wants to know more, please have a look at Hydeploy's website. Moving on to what we call our integral, which I'll just move back, sorry. At the bottom of this picture here, you will see a little site. This is called our Low Thornley site, where the blending will happen. But also at the Low Thornley site, apologies, we have what is called our integral site. So it's a large 15-acre source site at Low Thornley, which itself has a pedigree as being an outreach station for the old British Gas Research. So it's continuing its heritage as a research site. We are building our integrated transport, electricity and gas research laboratory. So this is going to be a fully integrated whole energy systems development facility. And it's a place for academia, industry, government, small and medium enterprise to explore and test new technologies, strategies, and green energy processes for transport, electricity, all in one place, all in one site. It's led by Northern Gas Networks in partnership with Northern Power Grid, Newcastle University, and more. And it's being used, as I say, to celebrate our capability of innovation. It's breaking down barriers for hydrogen, and we have numerous plans in different areas on site. It has a high pressure gas section that we can use. It has high voltage electricity, so it has real interesting future ahead. Part of that, what we intend to do, is build our hydrogen demonstration homes. And we intend to build a typical pair of semi-detached houses with 100% hydrogen appliances to allow the public, policymakers and other people to see that this can be achieved with the right impetus and the right policy. Practical demonstration, it's tangible. To see a hydrogen boiler for a customer, it just looks like a box on the wall, like your current boiler. Minimal disruption, help with the supply chain, and what I find as a former apprentice myself, to help with the green recovery and help train the next generation of green apprentices, training sites, DNV, Spade Adams site. We have this ready for people to start training on and looking at. So I'll leave a final thought. If the 19th century was dominated by town's gas and the 20th century by natural gas, could the 21st century be dominated by hydrogen? We'll see. And if anyone would like to follow us on our website, Twitter or email, please do feel free to contact.
Thank you very much, Dave. Mark, shall I take over now? Okay, as I say, yeah, thanks very much, Dave. Really appreciate that fascinating insight into great couple of projects there. And something that's obviously key to our low carbon kind of energy system moving forward. I was very interested in the work being done at Spade Adams, being an ex-RAF officer who's actually been to that site quite a few times. I've been very interested in the work that's going on there and the enduring kind of R&D work as well. What I did like is your reference to skills, and I think that's something that's often forgotten. I think as we move forward into a low carbon economy, I think skills is going to become more and more important. So just to start, there are quite a few questions coming in, so I think we ought to move straight on to those. But can I just start with a quick one? So I'm the chair of the Humber branch of the Energy Institute, and I'm also chief exec of Catch, which is an organisation that's put in a bid for the industrial decarbonisation cluster plan for the Humber region, the ISCF bid, Industrial Strategy Challenge Fund. Is there a link between the H21 work and the cluster plans that we'll be developing over the next couple of years?
The H21 project itself is a distinct unit, so to speak. However, the industrial and commercial consumers NIA that I mentioned is something that is looking at our industrial customers, of which the Humber is one. So there is going to be that engagement with larger businesses and larger industrial people for that. And if that's something that people want to start discussing with or speaking to us about, by all means, feel free to get in touch.
I think we might get in touch anyway. That's fantastic. Yeah. Thanks. I'll move on to the questions that have been coming in. So to start with, we've got a question from Andy Clark. The question is: this is a full Monty with complete transfer to hydrogen. What's the status of insertion of hydrogen into the current mix? And I think you led on to that, really, didn't you, with the second part?
That'll be the Hydeploy project, yes. That's one, yes. There's Hydeploy. There's also other GDNs looking at other projects, such as HyNet, which is Cadent as well, and there's others. Yes, so there are numerous blending projects looking at Hydeploy being one of them. That's just the particular one that NGN are involved with. Look at Hydeploy's website.
Yeah, and there's a number of projects right around the UK in all the different clusters. A follow-up from Andy was actually what I was thinking about at the same time as he's written this, is actually, is it a coincidence that the picture for phase 3 is at the time? And that's of great interest to me, actually, being in the Humber.
It's just a picture, to be honest, I put for the presentation. I was looking for a picture and I thought, well, yeah. Okay.
That kind of ties into my point about the link between the cluster plans, of course.
Yeah.
Because they've got hydrogen as an integral element of their planning.
It's one of our stock photos that I put in there, looking forward at that. And I live closer.
Yeah. Oh, yeah, we could tell. Okay, thank you. So the next one was from Steve Critchlow. Thanks, David. Thinking about accidental pipeline strikes, is there an increased risk of ignition And if so, is that risk tolerable?
That's going to come out in the research. I think that's the sort of things that are being looked at as part of all the sort of bigger phase 1, phase 1B research that's been done. I will be honest with you, I've not seen anything for that, so I can certainly have a word with Steve afterwards about that one, if there's anything we can find out.
Okay.
Pipeline strikes are going to be looked at with things. You've got to think about industry standards, such as IGEM documents are going to be reviewed for pipelines. IGEM are looking at reviewing all of their TD1, TD, so they're going to take into account any mitigation that may come up from the research, as well as the development of standards moving forwards for distance to properties, for example, depth of cover. So it will be a holistic view that all feeds into one pot when the research is done.
Okay, thanks for that. And then the follow-up is, given hydrogen has a lower CV than natural gas, can it really meet the energy requirements currently made on natural gas? Do we need to increase pressures? Or are we expecting to use less gas? If the latter, can that be done in time to roll out hydrogen?
I think you have to look at it from a larger picture. Yes, obviously hydrogen has about 3 times less the volumetric value, calorific value of it. So it needs about 3 times the volume to meet the same heat demand. And that's something I'm looking at with regards to network flows and network velocities to see, can the pipes take that and what implication does that have? And then we'll be doing research on velocities and erosion, that sort of thing on there. But yes, it can, and we're looking at it. It may need certain areas where pressure needs to be increased. It may need mains remediation, such as larger pipes to take over, to take that volume. But we are currently looking at basing the pressure on the same that we have at the moment. But yes, district governors may need pressure rising there. But with the iron mains replacement programme and the transition to more polyethylene pipes in the area, pressures can go up as well. So it's all in the mix as well. But we're certainly not looking at putting the pressures to 2 bar to the house or anything like that, no.
Okay, thanks. I hope you're okay to keep going because we have got a few questions coming in. I think there's some key topics here. So there's one from Peter Godfrey. Says, greetings from Singapore. As you know, hydrogen is now beginning to become a hot topic in Asia. How much focus is being put on the opportunity for greater international collaboration with the intent of reinforcing UK's hydrogen development aspirations?
There is a great deal of worldwide attention on hydrogen and also collaboration as well. Certainly Northern Gas Networks have been in contact and discussions with other partners around the world. I myself was in a conversation with a company in Australia not too long ago. So there is worldwide collaboration and looking at this on behalf. It's not very much a UK insular view of the world. So it is very much, I think, companies and governments around the world are now paying attention and looking at hydrogen with a real possibility.
I think we've got a huge opportunity here in UK PLC to really export what we're doing because there's some fantastic work going on. Okay, so next question is from Robert Barnes, and it's, is this the wheel turning nearly full circle? Town gas contained nearly 52% hydrogen in use for about 100 years until circa 1970. What past experience has been researched and incorporated into this study?
I think that there's going to have been a lot. Myself, I haven't been involved in a lot of personal looking at the past and moving forward. However, I think the biggest learning curve that we can take from the past is the conversion process. We've done it once, we can do it again. I think for me personally, that is something that we can really look at to see. We've converted a country and appliances in the past from one fuel to another. Well, we can do it again. It's not unprecedented. It's not unheard of. It's not pie in the sky idea. We can do it. So from that point of view, we can really look to our own industrial heritage and our industrial past for the future. So yes, possibly I'll be going full circle.
Great. Okay, they're still coming in. I hope you're okay still, Dave.
We've got plenty of water.
Okay, so the next question is from Domenico Mangiola, and it's, what do you see are the weaknesses in the project and for future transaction? Weaknesses in the project? weakness areas.
If someone wants to give us a few £billion, that would be nice to do something. Yeah.
Yeah.
I think weaknesses are going to come out as part of the research, aren't they? You're going to start looking at any project to think, right, well, we need to do more on this. And that's a continuous learning curve across any project, be it hydrogen conversion, be it on building a bridge. You start looking at the project and thinking, we need to do more work, which is exactly what we're doing. But weaknesses, you learn from them as you encounter them. I'm not aware of any specific weaknesses I can think of. I don't know what it fully means by weaknesses.
Okay. Well, we'll move on. The next one is from Natalie Lowry. And this, I think, again, is linked to my point about bringing your project together with the cluster plans. And the question is, have NGN considered the supply side in terms of green versus blue hydrogen? Also, does NGN see the transmission network converting to 100% hydrogen or a blend?
First of all, I'll deal with the NTS. The National Transmission System is something that National Grid are actively looking at the moment, and they have their own projects, High NTS, Future Grid, for example. So the transmission side of it, I can't speak on behalf of National Grid or the higher pressure tiers because that's not something the H21 project is looking at. But certainly, if you're interested in that, I would contact National Grid with regards to it because they do have their own project ongoing with that. We will be linking with them at Spade Adam on our distribution microgrid, as I mentioned, as part of their project. But what Grid decide to do and what their things are is for Grid. What was the other first part of the question, sorry?
This is about green versus blue hydrogen. Sorry,
we have our North of England report that was produced back in 2017-18 time. That did have proposals for all sorts of different hydrogen production in there. First of all, it started predominantly with ATR, moving on to different options. But at the moment, we're particularly focused on the conversion of the network to see how it will be done as opposed to the production at the moment. That will come with our NIA projects, but at the moment, it's not something we are actively looking at the production side. We are working with other people, as I say, the clusters who are looking into that, but it's not something we are specifically driving.
Okay. I think more of a message from Andy Clark is, after COVID, can I arrange a visit to the North East branch? I don't know how to put you two in touch with each other, but
drop me an email and I'll pass it on to the right people on stakeholder list. Yeah,
I think that's probably the best thing. Yeah. Okay. Next in, Duncan Botting. Thanks, Dave. Good presentation. Given the appliance of EU regulations allow a maximum of 30% hydrogen mix today, what's seen as the change over the timeline between 30 to 100% for both the network and the consumer appliances?
Well, appliance-wise, if you're thinking about the High for Heat project, there are hydrogen-ready appliances now. So manufacturers, and I'll not name any of them, but manufacturers do have hydrogen-ready appliances ready to go. So from their point of view, they're done, so to speak. Any policy driver to mandate their use is one for government, obviously. The transition between 30% and 100%, well, that will be dependent on policymakers giving that decision to convert. To say yes, based on the evidence that's presented, because the decision to convert, to go with hydrogen, the green light, so to speak, won't come from the gas networks, it will come from government. We will present the evidence to the regulator, to government, to say this is what it is, and the decision will be one for government when to proceed.
Okay, thanks very much. We'll keep going. So next one is from Thomas Imhoff. What types of local hydrogen production methods are being explored for live trials? We've kind of talked about the green and blue. Is there anything further really on that?
So for the live trials, well, I'll use Kiel, for example, because it's the one, the Hydeploy one. They're currently using an electrolyzer to theirs. So for local trials, that will be formulated as part of our, well, we're looking at it now as our pre-enabling works, how we might look to do hydrogen production. Will it be storage? Will it be, how are we going to do it? Depending, again, what is going to be on volumes, technology, what site is chosen, what infrastructure we have there. So all options are on the table at the moment, but we'd like to obviously keep it as green as possible.
Yeah, okay. And a follow-up, sorry, Bernie. are there any estimates regarding the cost of converting the current gas grid infrastructure to hydrogen? Cool. That's a big question.
Off the top of my head, there's been a wide variety of costs and estimates produced. I know KPMG produced reports with estimates in there. You've also got to look at how would conversion occur? Would we have to replace everything? How many pipelines do we need to put in? What do we do? So the costs can vary. All I can say is our North of England report that was produced estimated that gas bills to compare for conversion would be about 7% of a gas bill in 2035, round about that figure. That's a figure that sticks in my head, but there are others, and that could reduce with consumer usage reducing, efficiencies in that time. But yeah, there's all sorts of different figures out there. That's something, yeah.
Okay. Well, I think there's still loads of questions coming in. What I'll do is I'll just pick a few more at random. So I apologise if we don't get to everybody, but I'm just conscious that it's quite an inquisition of you for you, Dave. So I will try and just pick some more at random as we go through, just a few more, just to round off. So the next one, do we need to develop any new instrumentation to detect hydrogen and measure its content in natural gas?
There will be new instrumentation required, I imagine, yes. Hydrogen detection, but let's not forget that hydrogen isn't some sort of brand new etherical creation that's never been used in the past. It is well used around the world with hydrogen pipelines in use in Europe and America. It's used extensively in the chemical industry and other people as feedstock. So there are learning things that can be learned from both people. So equipment is available for hydrogen. It's not that we're starting on the ground floor to detect this mythical element that's never existed before. The technology is there. It's just how we may need to adapt it to operate in a network and supplying gas on a large scale with it.
Yeah, absolutely. Here's one. What do you consider to be the key barriers to public acceptance of the hydrogen technologies? It's interesting that you said about the safety, and safety is not one of the primary concerns for people, which I was quite amazed at.
Yeah.
So, yeah, what are the key barriers to public acceptance? So cost?
Main things from our initial phase one social sciences, it seems to be the cost, that people are concerned about the cost to them to convert, what disruption that they're going to be focused on. The other minor concern on the safety focus that they had more of a concern with wasn't so much the hydrogen in their homes, but the carbon capture and storage. What's going to happen to that when you say to people putting carbon under the sea? Well, what happens if? It's that sort of thing, but it will probably be cut to the public. As a member of the public myself, I think we all focus on cost, isn't it? Every penny's a prisoner. So I can imagine it as cost, personally.
Okay. And the next one, who makes the choice on switching consumers over to hydrogen? It can't be done on a house-by-house basis. That's quite an interesting concept to consider. Who makes that choice?
Well, it'll be a policy decision. Once the decision is made to either, if central government say, right, yes, no more natural gas, we're moving to hydrogen, then that'll be a case of, and this is where the engagement and bringing the customer with us is really important. Because if we suddenly knock on the door and say, hello, we've come to change your gas over, what? But if people are ready for this and it's a national rollout that they're aware of, they're fully engaged and they're on board, I don't see that being too many barriers. It will just be the case of like having the mains replaced in your street. That's hopefully the best. Some people may have had the new mains put in where we're changing it over now. Your gas is off for the day while we do it. We come in and we put the gas back on. The difference will be it'll be a different gas that comes through. Obviously, there's going to be new appliances, but will there be hydrogen-ready appliances by the time this happens? So it's a lot of what ifs, but the ideal scenario would be that we change the gas over, we purge and reel out your appliances, and away we go. Yes.
So actually linked to that then, there's a question here that says, you mentioned the replacement of gas boilers, so it's kind of linked to the people switching over. So you mentioned the replacement of gas boilers with hydrogen boilers in domestic properties. Is government investment for hydrogen boilers becoming difficult to secure because of incentives being provided to heat pumps?
You would have to ask high for heat for that, to be honest with you, because they're the people dealing with the downstream of the appliances. Yeah, so the as I mentioned, H21, we are up to the emergency control valve. Downstream is high for heat. However, there's not a competition between gas and electric. It's not this gladiatorial battle between it must be one or the other. We have to look at this climate change problem from a overview, all technologies approach, be it transport, be it, we can't have this one against the other. Every medium is going to have a part to play in this. Yeah.
And I think, to be honest, that's probably a great point to kind of round it up. It's going to be, a whole system approach. It's not, hydrogen is part of the, it's a key vector in terms of storage and transportation of energy. So that's absolutely fantastic. Thanks again, Dave. I'm sorry about that introduction, but I think there were so many fantastic questions coming through that what I wonder if we can do, and I'll have to ask the EI about this one, is whether we can round those questions up and maybe see if we can get some answers to those that we just haven't had time to ask.
Yeah, that's okay. Yep. And if anyone has any questions, please feel free to contact us. That's not a problem. We're here to try and answer your questions where we can.
Fantastic. And thanks again, Dave. Really appreciate your time. That's an absolutely fascinating insight into a fascinating project. Thank you.
No problem. Thank you, everyone.
I appreciate your time for coming on. And actually, I think what this has shown is, I mean, with the number of delegates, I think we were up to 100, just under 200 at some stage during the presentation. I think it shows the appetite for this particular subject. And I think there's got to be a potential for a follow-on at some stage. So we'll have to have a look at that to see if we can put on a follow-on webinar to see if we can update further on the hydrogen story. Mark, are you happy for me to kind of round up, or did you want to come in at all? Okay. So yeah, thanks, Dave. Really appreciate it. I hope you guys on the webinar have all enjoyed it. Thank you very much for your time. For those of you who are already members of the EI, please have a look at the work that the branches are doing. For the Humber, please feel free to contact myself, and obviously for the Yorkshire region, contact Mark Burrows. There's some great work being done in the regions, and our contact details are available on the EI website. You can get in touch with either branch through our section on the EI website, which is under the section of EI near me, if you want to have a look at that. For those who aren't currently members, the Energy Institute is a charitable chartered professional membership body. It brings together expertise to tackle urgent global challenges in industry. There's around 20,000 members, 200 companies, and 120 in 120 countries. And it's great that this webinar, for example, has got some worldwide coverage, which is absolutely fantastic. The EI dates back over 100 years. It started its life as the Institute of Petroleum and has morphed into the Energy Institute over time to reflect its current role. It's a unique, independent organisation spanning the world of energy, facilitating debates, championing evidence, and sharing fresh ideas, giving voice to issues or concerns and, where necessary, challenging industry. So it's a great organisation. It's a unique organisation. Please have a look at the website. And again, please feel free to contact myself or Mark or anybody within the EI if you want more information. In terms of the slide that's on your screen at the moment, I kind of want to highlight the bottom right-hand comment, which really, for me, kind of highlights the role of the EI, where it says that our ambition is for energy to be better understood, managed and valued. And that's the purpose of these webinars. And in line with that, I just want to highlight one more resource that's available, and that's the Guide to Hydrogen. I think we mentioned it right at the beginning. The title is Energy Essentials, part of the Energy Essentials resources, and it's a Guide to Hydrogen. And it provides information on potential benefits, challenges, and user experience with hydrogen in the home, transportation, and industry. It's evidence-based. It was peer-reviewed. It's aimed at those who aren't really experts in the field, so maybe not relevant to everybody on this call. But it sets out what hydrogen is, how it's made, how it's transported and used, and what the experience will be like in the home industry or for transport, and what the future of hydrogen looks like. So it's a great resource. It's available on the website, energy-int.org/hydrogen. So just if you're interested, have a look at that resource. So unless my colleague Mark has anything further to say, I'll just round up by saying, yeah, thanks ever so much everyone for attending. I think the number of delegates really does highlight the interest in the low carbon agenda, in hydrogen in particular, and of course in this particular project H21. So thanks again to Dave Tomkin for this very insightful look at the H21 project, and thank you for answering those questions. Look out for further webinars from the EI headquarters, from the branches. Have a look at our social media. We've got some great social media posts going out, and also have a look at the branch websites on the EI site. And my final point is, let's hope that we can get back some face-to-face meetings in the future. But this is a great medium to stretch out our voice and to get heard by a wider audience. So there's got to be some future for a blended approach. So thank you very much, everyone, and that concludes this webinar. Thank you.